Tommy Scherbel and Cuyler Frisby for Civil Engineering 594R Geoinformatics GIS Programming class at Brigham Young University. Today we're going to be talking about a TrailMaker program that we have created using Visual Studio. This program was supposed to create a standalone desktop GIS-enabled application that allows us, the user, to select a DEM and trail and plot the longitudinal elevation gains and drops and compute statistics related to the difficulty or ease of the trail. The user should be able to select from known existing trails from an imported shapefile or draw their own trail on a map. So today, I'm going to just show the actual program, and then Kyler is going to actually talk about the code itself. So here is our program. It's within our Visual Studio file. We could also open it within Visual Studio or just click on here. But clicking on here, I will first show the layout of our program. So as you can see, we have just the basic menu buttons up in the top left of our program. File, all we have there currently is the exit tab, which, as you can imagine, exits the program. The second one is edit. Here is where we can add layers. You can add any kinds of layers, like a DEM, which we already have automatically loaded. Here is the mostly Utah County DEM. But you can also add shapefiles and any kind of layers there. So we're going to just go ahead and add our first trail. Here we called it the sample trail, and you can barely see it, so we're going to use our view tab to zoom in on this beautiful trail. This is simply from the Clyde building to the temple, and all you have to do is click on edit and analyze the trail, and here you can see our beautiful trail cross section. You can see where it starts and where it ends. You can see how that you start at the Clyde building, go down towards 9th, and then you start heading up 9th, and it's pretty much an uphill battle from there. You can see the distance in miles here, and then in meters over here. You can it tells you the elevation change in feet over here and meters on our table. And then we give it an average slope in percentage, and then a calories burned. And we'll explain those later. But we also tell you to try hiking somewhere else, lazy, because that was an easy one. Please try somewhere else again. So, yeah, whoops. So I'm gonna show you how to do that again by just putting in your own trail. So let's say we want to hike Temp. I believe Temp is around here. So yeah, that has to be it. So what we're going to do now is we're going to draw a trail, and it tells you here that you can click on the map to draw the trail, and then you just double click it to stop the drawing. We're just going to start at the base and head up the face. So it's a basic trail, I know, but we could also go around and do it around here. But we're just going to show that and how this still works. So we're going to edit it and analyze the trail. We made it to the peak, we went over a little bit, that's okay. But that trail was so hard, so good one. But basically it was 3.8 miles. Yeah, you get the gist. That's it for showing how this wonderful application works. I'm going to hand it over to Cuyler, and he's going to delve into the depths of the wonderful coding. I did forget to show a few of the tabs here in the menu bar. We also have the zoom out and the pan buttons for when we're in the map. We can zoom out simply by clicking on that, or we can pan. The pan also makes it so you can zoom in and zoom out using the roller bar. We also have here the clear all layers tab. This will clear everything we have here in the map, in the legend, and here in the map. Currently we don't have anything inside the help tool, but we could potentially in the future have documentation for helping within this application. But just to show you the clear all layers tab, here it is. Woot.
Okay, thank you, Tommy, for showing us how this awesome application works. Now I will show you our project in Visual Studio and take you in depth a little bit on the source code to give you a better idea of how we put this TrailMaker application together. So as you can see, this is our form in Visual Studio. It looks very similar to the application when you run it. We have some menus here, which you've already seen, and this statistics panel is visible here, but the default property on that is, the visible property is set to false by default, so you don't see it until you analyze a trail. So let's go ahead and look at our code here. Pretty much all our code is here in one file. It was pretty manageable because this is a pretty simple application. So just taking you through this briefly. So for our first block of code here, we are initializing our global variables. This line drawing, which we called new line, is for use with this line drawing.cs file that we found from a plugin that was built for Hydro Desktop, which I'll talk about a little bit more later. This number of points is an arbitrary number. We chose 1,000 as the number of points along the trail that get plotted. And then this is for the total distance of the trail. And then these two arrays are for the x and y coordinates that will actually get plotted in our graph. So as you can see, they have the same amount of points as the number of points variable. Okay, so our first function here is just the main function that runs when the application is initialized. So we weren't able to get any user interface plugins working. We tried to get a base map up and running, but a lot of people had trouble with it, and we did too. So, but we did get the GDAL plugin working, so we can use, open any type of raster data. So the first thing we did is load those extensions that were saved in the application extensions or plugins folder over here. As you can see, we got the GDAL plugin in there. So we load those extensions. We set the default cursor mode to pan, so when you launch the application, your cursor will be in panning mode. And then we added that default raster layer to the map automatically. So when you launch it, you have something there to work with. That raster covers all the way from like Payson to Salt Lake, so it's a pretty good area for people that are interested in hiking around campus and the mountains near Provo. So continuing on, this function is also for when the main form is loaded. What we do is that new line variable, we link it to our main map for drawing a custom trail. So that's for use with this line drawing.cs file that we found. That's what made it so we could draw the line and have it show up as you draw it. Like I said, this line drawing.cs file we took from a plugin that was on the Hydro Desktop Codeplex site. Continuing on, the next few functions here are kind of the event handlers for the various buttons that are in the user interface. So this one here is the add layer button. As you can see, it's just a simple function to add a new layer to the map. This is for the exit button, closes the application. Zoom in button, we just changed to zoom in mode. Zoom out button, similarly we changed to zoom out mode, and same thing with pan mode. This one is just to remove all the layers from the map, as Tommy showed you. And then this one here, to draw a trail, to draw a custom trail on the map. As you can see, we call the activate line function from linedrawing.cs to begin drawing a custom trail. We also added a message box here that tells you how it works, to click on the map and then double click to stop drawing. So then we did new line.activate line, and that over here in linedrawing.cs took care of all of that, the specifics of that for us. So that was really nice to have. Our next function is plot points. This function is the biggest function we have. It does a few things. It computes the lengths of the trail segments, assigns elevations from the DEM to the points, and graphs the profile of the trail. So our first part of this function was just to initialize the variables that are particular to that function. You can see those all listed here. And then the very next thing we do, you can see it takes as an argument a list of coordinates. We actually haven't gotten to the part in the code where we call this function, but it takes a list of coordinates which we call points as its argument. So the first thing it does is it sends the points list to the getDistance function. So let me scroll down to show you where that function is located. GetDistance is right here. This function just gets the total distance between a set of points. So we send it a whole set of points, a whole sequence of points. The way that this function works is by actually calling another function called distance2, which is right here. That finds the distance between two specific points. So as you can see, the total distance variable adds each time through the loop, runs the distance2 function, and then adds that distance to the total distance, and eventually you end up with the total distance of the line. So back up to the plot points function. After we get those distances, we loop through each line segment. So for example, if you drew a line with 5 individual segments, it would go through those one by one. It reads a couple of the points into these variables a and b, and gets the size of the raster in this layer, in this variable. And then of the total number of points, which we chose to be 1,000, right here we determine how many of those points should be assigned to that particular line segment. So we do that by comparing the distance of that line segment, the length of that line segment to the total length of the trail, and then that ratio of points get assigned to that line segment. And then we calculate the spacing of the x and y coordinates for those points along that line segment. Getting a little convoluted here, but this just determines the spacing of the points along that line segment. And then this for loop, which is within that other for loop, goes through that current line segment and gets the map coordinates for each point along that line segment. And then within this loop, we have another one which gets the elevation data for the raster layer at each of those points. So it's a little complicated. We got 3 for loops going on inside each other. But the goal of all of this, the gist of it is right here. We read the distance and elevation to these x and y arrays so that we can actually graph it. So this x array, which is the distance along the line we've traveled so far, and then this y, which is the current elevation. So we add to these for each point, and we'll end up with 1,000 points. And then, yeah, and then we go ahead and we're able to graph that. So this code here we commented out. It was just something we used during debugging, and we kept it just in case we needed it later on. This is the portion of the code that actually graphs our profile of our trail. So this right here, we clear any curves that were already on the graph. We create the graph pane object, and then this point pair list we create from those x and y arrays that we just defined up here. And then we add that curve to the myPane object, and we set up some display options such as the title text and the axis titles. We ran these 3 functions to refresh the plot, and then we made to the table tab to make sure that the plot shows up. And then this portion calculates the trail statistics. We determine the average slope of the trail. If you hike all the way to the top of a mountain and then down again, it's not very useful because there's not much elevation change at the end of the day, but it's pretty useful if you're going like straight up a mountain for a one-way hike. And then as you can see, we did some rounding here to make sure that we only had 2 decimal places when these values are displayed. We use the total distance, the net elevation change, and the average slope. And then we very accurately calculated the number of calories that the average person would burn when hiking a specific trail. Don't want to get into the specifics of that. It's very scientific, but very accurate. So if you want to know how many calories you'll burn hiking the Y, this is the place to come. And then we added a little custom message here. If your average slope was more than 5%, then we give you a congratulations. You did a hard hike. But if it was less than that, a little reminder to push yourself a little harder next time. And then this finally makes the panel that shows the statistics visible. Okay, so we already went over these 2 functions, the getDistance and distance2. And finally here at the bottom, this is the Analyze Trail button. The first thing it does, this is really where all those functions above get called. We read in the line layer from the map, and we get the point from the line layer. We get a list of points, line point list here, which is what we pass to plot points. When I was up there, I said it takes a list of coordinates, so that's where that comes from. And then we call the plot points, which we just went through, and you have everything you could ever want to know about a trail given to you instantly. So that's our project. Thanks for watching our presentation.